Hello, and welcome to this course, Learning Teradata Vantage, where we explore various aspects of this database and analytics platform. We will start off with a quick introduction to Teradata, but before diving right in, here are some of the prerequisites for the course. I assume that you have at least some basic knowledge of relational databases, including tables, columns, and so on, since Teradata shares a lot in common with relational DBs, and I won't be going into the depths of some of the fundamental concepts, which means that I also expect you to have some familiarity with SQL, given that Teradata queries follow a very similar syntax. Towards the end of the course, we will explore connecting a Python application to Teradata, and for that, some Python experience will be helpful. Moving on then to the meat of the course, where we start off with what exactly Teradata is. Well, this is in fact the name of an enterprise software company whose flagship product is a multi-cloud database. Beyond that, Teradata also supplies analytics related products and services. The flagship product of Teradata is the Teradata Vantage database. This was previously called Teradata Database or simply Teradata and is the focus of this course. Vantage is in fact a multi-cloud data platform which is meant for enterprise-grade analytics, and this combines data lakes as well as data warehouses within a single platform. It is capable of handling very large business intelligence workloads thanks to its ability to scale both vertically and horizontally. Taking a closer look at Teradata Vantage, as touched upon, this is the flagship data platform for the Teradata company. It is a single platform for analytics. That is, this one piece of software combines the features of both databases as well as data warehouses. Essentially, this includes the transactional capabilities of databases and the analytics capabilities of warehouses. Like most enterprise grade warehouses, Vantage is capable of connecting to and sourcing data from a variety of different sources. Once data has been loaded into Vantage, it is possible for us to perform analytics operations using different methods. Its SQL queries cover the range of DDL, DCL, as well as DML statements. Teradata Vantage, though, goes beyond just SQL queries. We can perform advanced statistical as well as machine learning based operations within queries. Furthermore, we may also make use of high level languages such as Python and R to interact with Teradata Vantage. To understand why exactly Teradata Vantage is so useful, let's understand what goes on with traditional data warehouses. These are typically very large stores of data which can be gathered from many different sources, ranging from static files to streaming sources. And warehouses are meant for us to execute very long running analytics jobs. These may be based on SQL queries which operate on terabytes of data. Most warehouses contain historical data which has been gathered over multiple years, and they usually offer very little support, if at all, for transactions. Transaction support, however, is an integral feature of databases. These databases may be relational, document oriented, and come in a few additional flavors, but the support for transactions stems from the fact that these are meant for operational data, which is subject to regular changes. These deliver excellent performance when it comes to lookups of individual rows, updates, as well as inserts. What databases are not usually meant for is large scale analysis involving terabytes or petabytes of information. And that, of course, is the strength of a warehouse. So, databases and warehouses have their own strengths and use cases, which brings us to why exactly Teradata Vantage is so useful. It is a simple and unified platform which supports both transactions as well as large scale analytics. In short, we can have our cake and eat it too. Not only that, we can also carry out transactions while analytics operations are going on. So, in other words, this is an active data warehouse. To support the analytics operations, Teradata Vantage includes something called an advanced SQL engine, which optimizes query executions. And there is also a machine learning extension in order to perform ML-based analysis. For instance, to identify clusters in our data using the k-means clustering algorithm. The data we work with in Teradata Vantage need not all be stored within the system itself. It also integrates with data on external platforms. Beyond that, Vantage is available as a service on all of the major cloud providers: AWS, Microsoft Azure, and the Google Cloud Platform. Furthermore, it can also be set up on premises using VMware or Teradata IntelliFlex. And in fact, in the demos of this course, we will be setting up Teradata with VMware. Furthermore, hybrid setups as well as multi-cloud deployments are also available when using this database. All of these features give you some idea of why Teradata Vantage has had a loyal user base for decades. We will now take a close look at Teradata's architecture, which enables it to handle very large-scale analytics tasks and process them efficiently. We begin with a look at the concept of symmetric multiprocessing. This is also known as shared memory multiprocessing, and this is a setup involving multiple processors, and these may be scattered across multiple machines, but significantly, each processor is treated exactly the same way. So while the processors may not be exactly the same, they will be treated as such. All CPUs have access to the same shared memory as well as I/O devices, so symmetry is assumed in this regard as well. And as you may have guessed, the hardware which is used to support Teradata Vantage is based on symmetric multiprocessing. So in short, each CPU is just as likely as any other in the system to be assigned a particular task. Then there is the concept of massively parallel processing, or MPP, and this is where the SMP hardware is simply linked together with a communications network. So we may have hardware which is dispersed even across geographical locations, but they're all still connected. And this connection is made possible by something called a binet network. This includes a lot of the standard networking features such as broadcasting, multicasting, and point-to-point communication of messages. And with that, let's move over to the different layers and components which make up the architecture of Teradata Vantage. Clearly, there are many different pieces in here, so let's focus on some of the important ones one at a time, starting with the advanced SQL engine, which we have already touched upon previously. So Teradata, of course, is not just a database. It is a single platform which combines features of a database as well as the analytics capabilities of a warehouse. And it is the analytics capabilities that are enabled by the advanced SQL engine. This not only allows SQL queries to be executed in the most efficient manner, it also supplies various functions that are not part of standard SQL. And much of these functions are to do with advanced statistics and machine learning. Heading back then to the architecture diagram, another important component is the native object store, which adds to the flexibility of Teradata Vantage. There may be many occasions where the data which currently resides in an external platform will need to be analyzed, and with most analytics tools, this will require a migration of the data into the platform. This, of course, can prove very tedious and time-consuming, and beyond that, it is often a temporary measure since the data will often be removed right after analysis is performed. To avoid going through the trouble of migrating the data in and then removing it, Teradata Vantage's native object store allows us to directly operate on the external data. So we can leverage all of the analytics capabilities of Teradata Vantage without having to perform any migration. There are, of course, some limitations. The native object store only supports CSV, JSON, and Parquet files that are stored on S3 compatible platforms. Specific examples of such platforms include Amazon's S3, Google's Cloud Storage, Microsoft Azure's Blob Storage, and the NetApp Storage Grid. Another important aspect to keep in mind is that Teradata Vantage can be scaled quite easily. The nodes in the binet are loosely coupled, which means that adding and removing of nodes is quite painless, which also translates to the fact that Vantage can be scaled to thousands of physical CPUs, which in turn are broken up into tens of thousands of virtual CPUs, also known as vProcs. Back to the architecture diagram then, where we will now turn our attention towards the in-database analytics feature. This is in fact related to the native object storage, since it allows us to query data that lies in an external platform. These queries are enabled by the advanced SQL engine, which, as discussed before, supports standard SQL operations, but also offers support for various ML-related tasks, including data preparation and model scoring. When analyzing large data sets, we may need the help of some advanced statistical tools, for which there is the Vantage Analytics library, which includes hypothesis testing functions as well as options for feature engineering. So we can use statistical tools for ML. On top of everything in the architecture diagram are the interfaces to actually work with Teradata. And beyond the APIs, a number of high-level languages are supported. The most commonly used languages when working with Teradata include SQL, and as touched upon, this goes beyond just regular SQL and includes analytics and ML operations. And then we can perform similar tasks using Python libraries as well as the R programming language. Now that we understand some of the significant features as well as the architecture of Teradata Vantage, let's explore some of its most common use cases. Before we get into the details though, let's take a look at how analysis operations have traditionally been performed. Here, data from an operational system such as a relational database is periodically migrated into a warehouse. The data that is migrated may include sales recorded at a retailer. Over time, as more and more data is migrated, the warehouse becomes the single source of truth in an organization. If the record of a sale exists in the warehouse, it means it did happen. Once we have a large enough volume of data, we can perform all kinds of analysis operations in order to gather useful insights. For example, perhaps the sales of a certain backpack spike up just before the summer season. Such insights can be useful when it comes to guiding business decisions. Sticking with our backpack sales example, perhaps a company can launch a marketing campaign in the peak season in order to vastly increase sales. This traditional approach has been applied for several years and quite successfully in the case of many companies. However, this does come with a few limitations, especially with regards to the rate at which data is being generated in recent times. In the traditional approach, there is usually a large lag between the data being generated and its analysis, and this lag could often be a few weeks or maybe even months, depending on the migration schedule. This means that if there are any new patterns which emerge in the data, companies will be rather slow to respond to them. For a retailer, if a certain product gains in popularity for only a handful of weeks, it may be too late to respond to that trend in the case of traditional analysis. Beyond that, the traditional approach often involved the maintenance of several data platforms, one for operational data and another one for analysis, among others, which means that the overall application environment is quite complex, since each platform may require their own set of hardware as well as their own networks. Furthermore, different skill sets will also be required for each of the platforms, which in turn adds to the complexity of hiring. On the other hand, if an organization were to adopt Teradata Vantage, they will be making use of an active data warehouse. In other words, a single store for both operational as well as historical data. And it's not like we need to flip a switch to go from carrying out transactions to performing analysis. Both of these types of operations can go on at the same time. And as we have touched upon a few times already, the SQL in Teradata Vantage goes beyond the standard SQL and includes several statistical and ML-based operations. With that said, let's take a look at how exactly an organization, specifically an e-commerce platform, may make use of Teradata Vantage for transaction analysis. Each new sale that is recorded will be stored as rows in one or more database tables. Once there are enough transactions to analyze, a clustering operation may segment all of the purchases into specific clusters, and these clusters may serve as a base for further analysis. This in turn might reveal that there are specific clothing brands that happen to be very popular in certain regions. It may be a combination of these brands and regions which make up some of the clusters. Based on this information, a company may decide to procure more of the products corresponding to those brands in the regions where they're very popular, while not changing anything in the other regions. Beyond that, there are several other use cases for Teradata Vantage as well. Its machine learning capabilities make it the ideal tool for fraud detection and prevention in financial institutions, where each transaction can be classified as legitimate or potentially suspicious. Teradata Vantage also finds utility in identifying traffic patterns in cities, and a good analyst may be able to suggest actions to improve congestion. Vantage may also be used to perform sentiment analysis on various text data, for example, on product reviews on an e-commerce platform. Vantage may also be used to study supply chain data in order to identify areas of optimization. We will begin this course on Teradata Vantage by downloading and installing Teradata Vantage Express. This will allow us to set up and work with Teradata on our own machines, and we don't really need to make use of any cloud provider. You'll observe that in a browser window, I have navigated to downloads.teradata.com. In the middle here, there is a download link for Vantage Express, which will allow us to download an image for Teradata Vantage. Specifically, we will download the VMware image, which we will launch using the VMware Workstation Player. Before we can proceed with the download, however, we will need to set up an account with Teradata and then log into it. I have already created an account previously, so I'm just going to head over to the login link. If you do need to create an account, you can just head over to the register button and fill in the details. Once you are ready to log in, however, just enter the credentials. In my case, I have used the account of a fictitious employee in my organization called Alice. And then, once you are logged in, you will be taken back to the downloads page. And now we are ready to go ahead with the download of Vantage Express. You'll observe that the Teradata Vantage image can be run using VirtualBox, VMware, or UTM, which are three popular virtualization tools. Furthermore, there are images available for various versions of Vantage Express. The latest one at the time of this recording is 17.10, and I'll just use this link in order to download it. Of course, we will need to agree to the licensing terms. Let's move on and do just that. And this will kickstart the download of the Vantage Express image. You'll observe that for me, this has now been downloaded onto my local file system. I'll just pull up the directory where this download has taken place. This, in fact, is a 7-zip file and is about 3.5 gigabytes in size. Let's just double click in order to unpack. I have WinRAR set up on my system, and that is the utility which will unzip this file. I'll just choose to extract this to a specific location, but keep in mind that this particular image is over 20 gigs in size, so you will require a lot of free space on your system. I'll just navigate over to a folder where I'd like this to be unpacked. This is a tools directory on my D drive, and this will kickstart the unzip. Given the size of the image, this can really take a while. I have just fast forwarded the video though until this unpack is complete, and now can exit my unzip utility since we now have the image which we need in order to run Teradata Vantage in a virtual machine. As touched upon earlier, we can use either VMware, VirtualBox, or UTM to launch the VM. In the next video, we will download and set up VMware Workstation Player for this purpose. Having downloaded an image for Teradata Vantage Express, in order to run it in a VM, we will now download and set up VMware Workstation Player. For this, I'll just exit this window, and then from my browser, we'll pull up a brand new tab to navigate to the VMware website where we can download the workstation player. The specific URL to navigate to here is vmware.com/the country code, for me this is India, /products/workstation-player/workstation-player-evaluation.html. As you may have guessed, it is the evaluation version which we will now download and make use of in order to launch Teradata Vantage. Of course, if you already have VMware set up on your machine and have the capability to launch the image, you can go ahead and do just that. Otherwise, follow along with me and download the workstation player for your platform. For me, the evaluation version is available at this link, and the latest version at the time of this recording is 16.0. This is also available for both Windows and Linux. I'll just proceed with the download of the Windows edition, and in a few moments, this exe file has been downloaded to my file system. Let me just launch this by hitting this button, and then proceed over to the next step of the install. For this tool as well, we'll agree to the licensing terms. We'll then allow the path environment variable to be updated in order to launch VMware from the shell. And in fact, most of the other settings I'm just going to leave at the default values and just proceed over to the next step. You can set the shortcuts according to your own preferences. I'll just leave one for the start menu. And finally, we'll choose to go ahead with the install. In my case, this will be an upgrade. This could take a minute or two, but once that is done, let's move on and finish with this installation. And we are now ready to use VMware Workstation Player in order to launch Teradata Vantage in a virtual machine. Previously, we have successfully downloaded and unpacked an image for Teradata Vantage Express, and we are now ready to launch it using VMware Workstation Player. For that, you can use the desktop shortcut or start menu shortcut to launch the Workstation Player. In my case, I'm just going to navigate on my file system to the start menu shortcut. The link to the VMware Workstation Player is already highlighted. I'm just going to launch this from here. And I'll just choose to finish with the welcome message here. And following that, well, the player has started up. Let me quickly maximize this window in order to improve visibility. You'll observe that there is the option to create a new virtual machine from scratch. However, we already have a VM which we can launch. So let's choose to open a VM and then navigate on our file systems to where we downloaded and then unpacked the Teradata Vantage Express image. For me, this is in the D drive within the tools subdirectory. Within that, there will be a folder corresponding to the version of Vantage Express which was downloaded. And inside of that, there should be a .vmx file, which is in fact a configuration file used by VMware. And this will be used to launch Teradata Vantage Express within a virtual machine with a few useful utilities already packed in. We can now open this up. In a few moments, some of the configuration information for this particular VM will be available. For example, the guest operating system is SUSE Linux Enterprise version 12, and for me, a total of 10.7 gigabytes of RAM have been allocated to it. There is also the option to edit the VM settings, but I'm just going to leave everything at the default value and choose to play this VM. This can take a few moments. There will be notifications with regards to specific settings. I'm just going to dismiss the notification though and stick with the default values. And in a few moments, the guest OS begins its boot up process. I'll just allow this to go on with the default values. So it is the SLES version 12 which will be launched. This can take a few minutes though. I'll just fast forward the recording until the point where user input is required. Specifically, we will need to supply login credentials in order to log in to our OS. I'm just going to enter the username of root and then hit enter. And following that, the OS UI begins to load, and we are notified that only authorized users may be permitted beyond this point. After dismissing the message, again, the credentials are asked for. I'll specify a login value of root and a password which is also root. Once that is done, we will soon be connected to our virtual machine, and this is the desktop of the VM. You will note that there are shortcuts available to Teradata Studio Express, which is a client which can be used to connect to and run queries against Teradata Vantage. There is also the Start Teradata shortcut, which can be used to launch the database on this platform. It is possible that the window for this virtual machine is a little smaller on your own system. This is something which can be adjusted. If you just scroll along and then pull up the menu from this top right, we can just head over to the settings section, and then from the settings for the virtual machine, we pull up displays under hardware. Here we can select the specific display on the guest operating system which needs to be adjusted, and this is where we can set the resolution. For me, this is already set to 1280 by 768, which is large enough for my own purposes. So I'm just going to leave it at that. Though you can also see that there are various other values that can be set here. I'm just going to cancel out of this view, however, in which case if you have made a change, you can hit apply. And then let's exit the displays configuration. And in the next video, we will start up Teradata Vantage on this virtual machine. It's now time to start up Teradata Vantage on this virtual machine. In fact, Teradata should already be up and running. And to confirm that, we can pull up the GNOME terminal, which is the shell on this guest OS. And from here, we can execute the command pde state-a. PDE is short for Parallel Database Extension. And if you get an output such as this one, where the PDE state is run/started, it means that Teradata Vantage is already up and running. There is a possibility though that the database has not automatically started up in your case, and in order to explicitly launch the service, you can run the command /etc/init.d/tpa start. If, like me, you're running this command when the Teradata database is already up, you will get the message that PDE is already running. Another option to launch Teradata, if it is not in a running state, is to use the shortcut which is on the desktop and is labeled Start Teradata. Now that we know that Teradata Vantage is running on the system, we can exit the GNOME terminal and then connect to our database using a client. More specifically, we will make use of Teradata Studio Express, which is already packaged within this virtual machine. A little later, we will make use of Teradata Studio from the host OS and then use it to connect to the Teradata Vantage system within our virtual machine. For now though, let's just make use of this packaged version of Teradata Studio. Once the Studio has been launched, let me just quickly dismiss the welcome messages which pop up. There are quite a few of these in this introductory tour, so it might take a minute or two. And then when the close option shows up, let's just click on it. And we are now ready to begin using this client. The first thing we will need to do is to set up a connection to our Teradata Vantage database. From the dialog which pops up, let's choose the Teradata connection profile. We will need to set up a name for our connection. I'm just going to call mine Looney Teradata and then proceed to the next step and then fill in the details of the database connection. The database server lies on the local host, so I'll just specify that. As for the username and password, the value is the same for both of these, dbc. I'll just choose to save down the password in the client, and then let's test out the connection to make sure that everything is wired correctly. If that is the case, you'll get this success message, which means that our client is now connected to the database and we are ready to put it to use. Let's exit this message and then finish the connection settings. And soon enough, in the navigator menu, our new connection is now listed. Within this window, I'm just going to scroll up to reveal that we are currently in the administration view. But what we really want to focus on now is query development. So let's just switch over to that interface. And from here, you will observe that a SQL editor pops up. We can write down our queries here and then execute them. Any results which are returned by the server will pop up in the Teradata result set viewer. And the history of query executions will show up in the SQL history tab at the bottom. In order to explore our database connection, let's expand the connection itself from this data source pane. And you'll note that there is an item corresponding to a DBC user. On expanding that, there is a subfolder of databases. And when we expand that, well, a whole host of system-generated databases are available for us to view. In the next video, we will add a new database of our own to this list by running a SQL query. Let's move on and create a new database within our Teradata Vantage system. And for that, we can execute this query. I assume that you already have a background in SQL, in which case the command create database should be familiar to you. So we create a new database called restaurants using this command. What may be new to you, however, are the permanent and spool keywords which we apply here. When we create a database as permanent, it means that its data will be stored on a permanent basis, and this will not be a temporary table. Following this, we specify the amount of space to be allocated to this database. Here we set this to a value of 60 E6, which equates to a total of 60 megabytes of storage. 60 E6 of course translates to 60 multiplied by 10 to the power 6, or 60 million bytes, that is 60 megabytes. The spool setting corresponds to the number of bytes to be allocated for volatile temporary tables. Here we set this to a value of 120 megabytes. To execute this query, we can hit the play button in this interface, and you will note under the Teradata SQL history that a new entry now pops up here, corresponding to our most recent execution. The question, however, is whether our restaurants database has been created, and in the data source menu on the left, as we scroll along, we won't initially see this restaurants database. However, if we were to right-click on the databases folder and choose to refresh, that database now does pop up. In order to view the contents of the restaurants database, we can simply expand this particular item from the menu, and you will note that a database is essentially a logical grouping of indexes, macros, stored procedures, tables, user-defined functions or UDFs, and views. To view the list of tables, we expand this particular folder, and as you might expect, there are no tables in here at the moment. That is something we will address in the next video, where we will create our first table in Teradata Vantage. Let's continue building upon the restaurants database which we created in the previous video. And as you can imagine, this is one which we will use in order to store details about various restaurants, and those will be stored in a new table which we are about to create. Let me just paste in the query for that, and I'll just scroll up where you can see exactly what the table is. The specific command which we run here is create set table, followed by the name of the database where the table needs to be created, which is restaurants, then a dot, and then the table name, which is Michelin or Michelin underscore awarded. The data within this table will correspond to those restaurants which have been awarded some kind of Michelin recognition. And then within parentheses, we specify the schema for this table. Now, most of this will be familiar to you if you have used SQL before. What may be new to you, however, is the use of the set keyword. A set table is one which does not allow duplicate entries. This is as opposed to a multi-set table where duplicates are permitted. Moving on then to the schema for the table, starting with the global ID column, which we set as an integer. There is the restaurant name, which we set as a varchar. We also have the address and location field for the restaurant. And then there is a min price and max price, which gives you a range of how much you can expect to spend at the given restaurant. Keep in mind that all of the restaurants which we will store in this table have been conferred some kind of Michelin award. So the prices can get rather high, and we will run a lot of queries which operate on these price columns. The prices, though, are not all in the same currency, and to indicate exactly what currency the prices are in, there is a separate currency column. So if the prices are in Japanese yen, then the currency column will have a value of JPY, and in the queries we will explore later on, we will use the currency field as a proxy for the restaurant's country or region. There are also other fields which we have in the schema here, including a phone number, a URL to the restaurant's webpage, and the specific Michelin award which they have been given. Once we close down the parentheses, we specify a unique primary index for this particular table and then specify the value of one of the columns in the table, specifically global ID. This means that the global ID column will effectively serve as the partition key for this table, and the hash value of the global ID will be used to determine the virtual storage node which the row will fall into. If you come from a background in relational databases, you'll observe that there is no primary key definition in here, and that is not quite so important if you're using the data for analysis purposes. Let's move on and execute this query then. You will note that one more entry pops up in the SQL History tab, and there is no error message associated with it, which means our table has been created and is now ready for use. Let's populate it with some data by running an insert query. So I'll just replace the current contents in the SQL editor, and this is what the query looks like. In fact, this insert statement is identical to one which you may have used for any relational database. Insert into, followed by the table name. In this case, we point to restaurants.Michelin awarded, and then within parentheses, all of the different columns for which data will be inserted. I had just specified all of the columns in here. We then close parentheses and specify the values following the values keyword. You'll observe that I'm adding the entry for a restaurant called Aqua, which is located in the city of Wolfsburg in Germany. The data we're about to add to this table is included in the course materials and can also be downloaded from this location on kaggle.com. Scrolling along, you can see that a meal at this restaurant costs 225 euros, which is certainly a hefty amount, but from the last column you can gather that it has been awarded 3 Michelin stars, so perhaps that price should be somewhat expected. We are less concerned with the restaurant itself, however, and it is the execution of this insert query which is more relevant. Of course, before we do this, note that numeric values are not specified within quotes, while text or varchars are specified in single quotes, just as we would in standard SQL. With that, let's execute this query. And following this third execution, we now have some data in our table. Let's confirm that the insert did in fact take place, for which we can execute this select query. Simply select star from restaurants.Michelin awarded. And sure enough, the single row of data which we entered now appears in the results pane. This means that we have now made use of Teradata Studio in order to interact with a Teradata Vantage database. Now that we have taken the first baby steps towards working with Teradata, in the next video, we will explore one more client which can be used to interact with this database, which is the BTEQ or BTEQ shell-based program. Teradata Studio is one useful client in order to work with a Teradata database. We will now explore the use of a shell-based utility called BTEQ, which can be used to interact with Teradata. First, I'm going to exit Teradata Studio on this guest OS, and we will return to Teradata Studio later on after setting it up on our host OS, that is on our own machines, rather than on a VM. Any SQL scripts that have been created can be saved. I'll just choose not to save in this case. And now, in order to launch the BTEQ or BTEQ utility, we will need to pull up the shell on our host OS, which is the GNOME terminal. From here, we just run the command BTEQ. The moment we do that, we enter the BTEQ shell, and we will be prompted to enter a logon command in order to connect to a Teradata database. We can do that by running a command like this one, .logon, followed by the host of the Teradata instance we wish to connect to. I have just specified the local host in here, then a slash followed by the user. The default user that has been created here is DBC. When prompted for the password for this user, we enter DBC once again. BTEEC will then start to set up the connection, and soon enough, we get the message confirming that the logon was successfully completed. This is where we can now execute queries directly against our database. And let's do something simple. Select name and award from restaurants.Michelin awarded. Remember the semicolon at the end, and then hit enter. And this should give us back the result of our query execution. The name of Aqua and the award of 3 Michelin stars has been returned. However, you will observe that the awarded column has been truncated. So we only see 3 MI rather than 3 Michelin stars. However, we will later explore how this truncating can be prevented. For now, however, we have explored the use of 2 different clients in order to work with a Teradata database. We will later set these up on our own machines in the host OS and then access the database from there. For now, however, let's just type in the command .quit in order to exit BTEEC. Once that is done, let's see how we can shut down the Teradata database. We can simply run the command tpa reset-x along with the message trying a shutdown. At this point, we will be prompted for a confirmation that we do wish to continue with the shutdown. To keep everything running for our course, however, I'm just going to hit no, and then the request will be aborted. We can also exit the GNOME terminal. And before we move along to the next demos, we can also shut down this virtual machine by hitting this power off button and then hitting power off once again and confirming that we wish to turn this VM off. This will initiate the shutdown process, and in a few moments, the VM will be in an off position. So far in this course, we have been interacting with our Teradata database running inside a virtual machine by using clients inside that same VM. Realistically, however, we will run clients from our own machines and then connect to a remote Teradata Vantage instance. We will now simulate that, for which we will require Teradata tools and utilities for our own machine. Here, I have navigated to the page where Teradata tools and utilities for Windows can be installed, and take a look at the URL in my browser address bar. Alternatively, you can simply use your favorite search engine in order to search for Teradata tools and utilities for either Windows or Linux, and you should be directed to such a page. From here, let's choose to download the latest version of the tools and utilities. For me, this is version 17.10. As always, let's agree to the licensing terms and conditions. And you'll observe from the bottom left of my screen that it is a zip archive that is downloaded. I'll just open this up and choose to extract the contents over to a specific folder on my file system. I'll just navigate over to D drive and then the same tools folder where the VMware image for Teradata Vantage was unpacked, and then choose to unbundle this zip archive in here. Once that is complete, we'll exit this archiving utility. And let's switch over from the web browser over to the File Explorer. Windows Explorer if you're on Windows. I'll just get into the Teradata Tools and Utilities base folder and then hit Setup in order to kickstart the installation of the tools. I'll just hit Next to proceed. And then from this menu, we can select exactly what utilities we would like to install. I have selected the first 6 in here, which includes BTEEC and also the ODBC driver. And I have also included fast export, fast load, multi-load and tpump, though it is mainly BTEEC we'll be working with. Scrolling along, you'll observe that there are also utilities available to link up Teradata with other systems. For example, there is a Kafka Access module if you'd like to connect your Teradata instance with the Kafka event streaming platform. There are also modules available to link up Teradata with Microsoft's Azure and the Amazon S3 service. Let's just stick with our selections then and choose to install. And once the installation is complete, we are ready to begin using BTEAC from our own machines. So we don't need to log into the VM for that. However, I have now brought up the VM in order to figure out the address at which Teradata can be accessed. We will need that in order to connect any utility which we run on our host machines over to Teradata running on this VM. So let's pull up the GNOME terminal and then run the command ifconfig, which is a network management utility. And importantly for us, this includes the inet address of this particular VM. This is the address which we can use to connect to this VM from within the same network. And that network, of course, includes our host machine, which is hosting this VM. Once this address has been copied over, note that for me this is 192.168.1.8. You may have a slightly different address. From here, let's switch over back to our own machines and pull up the command prompt. Here, I have brought up the Windows command prompt in administrator mode. Just in case you're unfamiliar with this utility, you can just search for CMD or command prompt from the start menu and then right-click and choose to open in administrator mode. In the next video, we will launch BTEAC from the command prompt. To run the BTEAC command line utility from the Windows command prompt, we first need to launch it in administrator mode. And then from the prompt which pops up, let's just run the command bteq and we will be taken over to the BTEAC shell. Then to connect to our Teradata Vantage server, which is running on our virtual machine, we run the same .logon command, but then as the host name, we specify the inet address which we just copied over from the GNOME terminal. Just to be clear, this will set up a connection from BTEAC, which we're now running on our host machine, over to Teradata Vantage, which is running in a virtual machine on this host. As we did before, we specify the DBC user in this command, and then we will enter the password of DBC as well. And soon enough, we should be successfully logged on to the same Teradata Vantage server. Then to confirm that it is the same Teradata database we're connected to, let's run the command database restaurants, which will make restaurants the active database for all subsequent commands. Again, make sure to include the semicolon at the end. And when we run this, first of all, there is no error, which is definitely promising. And in fact, restaurants has been set as the default database. Let's confirm the contents of this database by running a select query against the Michelin awarded table. So we run select name, location, URL, and award from Michelin awarded. Given that restaurants has been set as the default database, we don't need to specify the database name in here. When this is executed, soon enough, the name of Aqua and the location of Wolf show up in the results. However, you will observe that once again, the output has been truncated. The actual value of the location column in this row should be Wolfsburg. To prevent this truncating, we can explicitly set the width of each row, and I'm now going to set it to a very high value of 65531 characters by using the .setWidth command. This will cause the lines to overflow into a next line. So we will now make use of a separator in order to mark a line between the different values in each row. And by running this command, set separator, followed by a pipe symbol, we ensure that there is a pipe between each of the values. And then when we re-execute the same query to select 4 different columns from Michelin awarded, well, it is those 4 different columns which now appear in the results without any form of truncating. The values are of course a little hard to read. However, given that we only have a single row in the output, we can clearly see the restaurant name of Aqua, the location of Wolfsburg, the restaurant website URL, and the fact that it has been awarded 3 Michelin stars. The pipe symbol also appears before these values, and that of course is our separator. Having successfully executed individual queries using BTEAC, let's just exit by using the log off command. This will disconnect us from our Teradata Vantage database, but we're still connected to BTech. To exit that itself, we run .exit. And once that is done, let's switch gears a little bit and take a look at a script which you can execute using BTeek. We'll turn our attention to that in the next video. Now we turn our attention towards writing and then launching a script using the BTeek utility. I'm going to place the script file in the same C drive/user/administrator directory from which I will later launch BTeek. And this is what the script looks like. It's called restaurants batch insert.sql, and as the name suggests, we use this in order to insert multiple rows of data into the Michelin awarded table in the restaurants database. The script will be launched from within BTeek, so we start off with a logon command and connect to the Teradata database running in our virtual machine. Make sure you substitute your own INET address in place of 192.168.1.8. Then we specify /dbc for the username and then dbc once again after a comma for the password. Any output which is generated by the execution of queries can be directed to an export file, and it is that configuration which we set next by running .export and set file is equal to ddrive/teradata/out.txt. We will later on run a select query whose result set will be written out to this file. And then, well, the commands should be familiar to you. We run database restaurants so that becomes our active database, and that is followed by 3 insert statements. There is nothing new in the statements themselves. It is just that each of these corresponds to a new restaurant to be added to our table. The first one has a name of Zoldering, and this is in the city of Amsterdam in the Netherlands and is awarded 1 Michelin star. The second one, called Arhan, is in the city of Bangkok in Thailand and has 2 Michelin stars. And the third restaurant is one in Osaka, Japan, which has a single Michelin star. Following the inserts, the plan is to run a select query, but before that, we set the width of the output to 65531, set the pipe as the separator, and simply run select star from Michelin awarded. Finally, we run log off to disconnect from Teradata Vantage and then exit to quit the BTeek client itself. Now that we have this script in place, let's go ahead and execute it, for which we head back over to the command prompt. Just as a quick reminder, I have saved down the script in the same C users administrator directory. Next, we launch the BTeek command line interface, and then from its own shell, this is the command we can execute in order to launch our script. .run file followed by the path to the script which needs to be executed. Since I have restaurants batch insert.sql in the same directory, I'll just specify the file name itself, and soon enough, some output will be generated. Scrolling along, you can see that each of the commands in a script were executed, starting off with the logon command. Scrolling along, we can see the inserts, and then finally the select query. One detail which you'll recall from the script is that we had set an export file location. For that, we will need to navigate over to the location itself. For me, this is in D drive/teradata, and the name of the file is out.txt, which I'm now going to open up with the VI text editor. And from the output, we can confirm that all of the rows which we inserted have been returned in the output of the select query. And now that we have successfully executed a script, let's exit from this particular editor by running :q and then exclamation point. And now that we have some more familiarity with the BTeek command line utility, we will switch back to the use of Teradata Studio in the next video. Earlier on in this course, we made use of the pre-installed Teradata Studio, which was available in the VM containing a Teradata Vantage server. It is far easier, however, for us to set up Teradata Studio on our own machines, and for that, you can pull up a browser and then navigate to downloads.teradata.com/download/tools/Teradata Studio. The latest version at the time of this recording is 17.10, and I'm now going to download the Studio variant available for Windows, which is available as a zip file. As always, we'll agree to the licensing terms, and once the download has completed, we'll unpack the zip file as we have done a few times already, so I won't go through all of the steps in detail. We'll extract to a specific directory on my file system. So for me, this is going to be in the tools directory of my D drive. The unpacking of the archive will take a while, and once it is complete, let's head over to the unpacked directory, and within that there is a setup file which we can launch. I'll just select the language which I prefer, and then hit next in order to launch the installation process. Agree to the licensing terms. We will need to set a Java runtime environment. I have version 1.8 set up already, so I'll just point to that. And then set a default workspace location. I'll just keep all of the default values and then keep hitting next. Can configure whatever shortcuts are required and then move on. Then once the details have been specified, we hit install. This could take a couple of minutes, so I've just fast forwarded the recording to the point where we can finish with the installation. And now that we have Teradata Studio set up on our machines, let's launch it by using any of the shortcuts which we have created. I'll just head over to the Start menu and then scroll along in the list of applications down to Teradata Studio. Then we go ahead and launch it. From here on, things will be similar to what we saw before when we launched Teradata Studio from the VM. I'll just cycle through all of the steps in the quick tour. And then finally, we'll hit the close button. Alternatively, you can hit the close button at the top of the tab. Then from the connection profile settings, let's choose Teradata and then set a name for the new Teradata connection we are about to create. I'll again call this Looney Teradata and then hit next. This time for the database server name, we will need to specify the INET address which we used just moments ago in order to connect to our Teradata Vantage database from BTeek. For me, the address is 192.168.1.8 and the username and password are both DBC. Again, I'll set save password and test out the connection, and you should see a successful message. With that done, let's quickly finish the connection settings. And now we are ready to run queries once again against our database, but this time from our own host machine. I'll switch over first to the query development view, and then from within our database connections, we'll expand the newly created Looney Teradata connection. Then for the DBC user, under databases, sure enough, our restaurants database is present. When we expand this and specifically the tables folder, you will note that the Michelin awarded table now shows up. In order to execute queries, we can either type them by hand or we can use a little help which is available. If we right click on the table name and head over to Teradata Generate SQL, we have options available for some pre-configured SQL statements, including inserts, updates, deletes, and of course selects, which we will now choose. This brings up a select query within the SQL editor window, and you can see that all of the different fields or columns in our database have been included, and each of the field names are specified within double quotes, which allows us to reference fields which contain certain special characters. In any case, let's go on and execute this query, and the output gives us back the 4 different rows which we have added to the table so far in this course. Let's scroll along and confirm that all of the data is in fact available. Now that we have set everything up to run queries from Teradata Studio on our own machines, in the next video, we will explore some DDL statements. In this video, we will focus on DDL statements which can be run against a Teradata database table. But first, let's see what happens if we were to trigger an error in our execution. In this particular query, The from clause includes the database name dot table name, so it is clear exactly what database is being referenced. This is because there is no active or default database which is set. So let's see what happens if you were to remove the database reference altogether and then execute the query. Well, we get an error, as you might expect. In Teradata Studio, in either the result set viewer or the SQL history viewer, we can just double click on a cell in order to view its contents in a separate window. Here the message points to the fact that Michelin awarded is not recognized as an object. And this is because the context which is required, namely the database in which it is present, is not specified. For that, we can first run the query database restaurants, as we have done before when using bteak. This is the equivalent of the use database command in other database systems. Let's execute this command. And once that is done, I'm just going to do a little bit of cleanup by removing this other SQL editor. We already have quite a few frames to work with, so minimizing the number of tabs should help. And then replace this particular query with the same one where we run select on Michelin awarded without referencing the database. Now when we execute, sure enough, the results appear in the result set viewer. Now we are ready to move on to the DDL statements. And we start off by revisiting one DDL statement which we ran earlier in order to create the Michelin awarded table. When we run the command show table Michelin awarded, this will return to us the statement that was used in order to create the table. I'll just double click on the cell and the entire query pops up in a separate window. What we executed was create set table restaurants.Michelin awarded, but you will note that various configurations have been set by default. For example, fallback has been specified, and this is used in order to create a duplicate copy of the table which we can fall back on. This was done by default. There are some other default configurations, and further down we have the schema which we defined on our own for the table, followed by the specification of the unique primary index. A team may choose to save down this particular definition so that the table can be recreated later on if needed, and maybe even save this down in a version control system. While this particular view does allow us to access the schema of the table, there is another command which we can execute only to view the different columns that are present, specifically help table Michelin awarded, will return to us a result set containing one row for each column in our table. And you can see that various properties of each column are listed here. As of this moment, there are a total of 13 columns in this table, but now consider the case where we would like to add a 14th one. For that, we can make use of the alter table statement, as we would in most relational databases. The statement goes alter table Michelin awarded add, and then the name of the new column to be added, and then its type. Here we add a column called cuisine to represent the type of cuisine served at the restaurant and set its type to varchar. There is also the option to set a default value when no value is specified for cuisine. So by specifying default followed by the string yet to be added, well, we will see the effects of this particular alteration in just a moment. First, let's run this in order to add a 14th column to our Michelin awarded table. And then to confirm the change in schema, let's run help table. Scroll along to the bottom where cuisine appears as a new column. As a quick sanity check to confirm that the definition of the table has in fact changed by the addition of the column, we run show table, expand the output once again, and sure enough, cuisine now does show up within the table definition. Next, let's see what has happened to the value for cuisine in the already existing rows in the table, given that we have specified a default value. So we run select for the name, location, and cuisine. And for each of the existing rows as well, the default value has taken effect. Having added a new column to the Michelin awarded table, we will now execute one more alter table command this time to drop one of the existing columns. So by specifying drop followed by the name of one of the columns, Michelin link in this case, well, after execution, we will have one column less in our table. We can confirm this by running show table, and then in the new definition, well, Michelin link is no longer present. Let's see what it takes to drop multiple columns within a single statement. We will focus on the latitude and longitude columns next. So we head back over to the SQL editor, run alter table Michelin awarded, followed by two drop statements separated by a comma, drop longitude, drop latitude. To drop even more columns, we simply add more drop clauses separated by commas again. Once that is done, let's once again run show table Michelin awarded. From the output, well, the definition now no longer includes the longitude and latitude columns. Now consider the case where we would like to modify one of the existing columns. For example, location is now set to varchar 50, so we can have a maximum of 50 characters in that column. To expand it to say 80 characters, we head back over to the editor and execute this alter table command. We include the add clause once again, so this is effectively like adding and overwriting the existing location column, and then we specify varchar 80, so we can have 80 characters in here. After execution, and then running show table once again, well, the new definition now points to the fact that the location column will have a max of 80 characters. In the dataset we've been working with, the location column in fact points to the city in which the restaurant is located. So let's make things a little clearer to the end user by running this alter table command with a rename clause. Rename location to city will, well, rename the location column to city. As always, after executing this query, I will run show table once again, where the new definition does convey that city now appears as a column and location is no longer part of the schema. Moving along from altering the schema to deleting the contents of the table. Before that though, let's run select star and confirm that our table contains a total of 4 rows at the moment. A little later in the course, we will populate this table with many more rows. But before that, let's run this query in order to get rid of the existing contents. Delete from Michelin awarded all. This is the equivalent of a truncate statement in many relational databases. After execution, let's confirm that the table is empty by running select star and nothing appears in the result set. From cleaning out the table, we can move on and see what it takes to remove the table entirely from our database. And the command will be all too familiar for anyone who has experience with SQL. Drop table Michelin awarded. This seems to have gone through successfully. And to confirm, let's head over to the databases folder in the Data Source Explorer, right-click and choose to refresh. The restaurant's database is still there, but when we expand and head over to tables, well, that folder is empty, confirming that the Michelin awarded table has been dropped. We will now focus on various queries which can be run against data in a Teradata table, but for that, we will need a table containing data. We had previously dropped the Michelin awarded table, which we created within the restaurant's database, but now we will switch over to the data transfer view in order to create the table and populate it with the contents of a CSV file using the data transfer service. From this view, let's head over in the Data Source Explorer to the databases, and then within our restaurants database, we head over to tables. Here we can right-click, head over to Teradata, and then Data Transfer. This will bring up a wizard which we can use in order to create a table and load it with data using the UI. So we will be using the Looney Teradata connection and loading into the restaurant database. The source type can be set to external file, while the destination type is fixed at Teradata. Let's choose to launch the Smart Load wizard for the data transfer. And then there are a few details which we'll need to specify in this form, starting with the input file. Here, we can head over to Browse and then navigate to the location where we can find the file on our file systems. I'll just head over to a datasets directory which contains this file, michelin18.csv. Note that this is included in the course materials, and the file may also be downloaded from this location on kaggle.com. Opening up this file in a smart load wizard will set our input file, but there are a few other configurations which we will need to change from the defaults. First of all, this dataset does contain column labels in the first row, that is, it contains a header row, so we can check this box. As for the file type, delimited text is the correct value. However, expanding this will point us to the different types of files we can import data from into Teradata. So Excel formats are supported. Everything else we leave as the default values. Moving on to the next step. This is where we get a preview of the contents of the table, but there are other details which we can specify, starting with the table name. I'm going to leave this for the moment at Michelin 18. As for the primary index, from the drop-down menu, you'll observe that the options available are unique, not unique, and no primary index. You'll recall that the primary index determines the distribution of the data among its various access module processors or AMPs, which are effectively virtual processors or virtual nodes. This can be based on a unique key which is present in the data, and in our case, it is the ID column, which is the first column in the dataset, which fulfills this purpose. Next, we can set the table type to either multi-set, where the table may have duplicate values, or set, where there aren't any duplicates. I'll choose set in here, and in the preview below, note that the name field has been set to a type of varchar61. So the name of the column, name in this case, matches the header which was present for the corresponding column in the CSV file. And the maximum length found for the name contents was 61 characters. So the type has been set as varchar61. Similarly, the longest address was 115 characters. So the type for that column has been set to varchar 115. So the types and the lengths have been set automatically based on the existing contents of the CSV file. And we can change the types by hitting the three dots next to each column type, which may be required if additional data might be inserted into the table. Heading to the next stage of the data transfer, we can confirm the SQL which will be used in order to create the table. And here you will observe that the SQL is very similar to what we used previously in the last iteration of the table. So we have create set table. The table will be named Michelin 18 at first. The columns are ID, name, address, location, min price, max price, and so on. And you'll observe that the types for each of these columns have been picked up automatically based on the contents. So we have integer for min and max price, and decimal for longitude and latitude. I'll just choose to finish with this existing definition, and you should get the message that the table has been successfully created. Let's exit this wizard then. You'll observe that a transfer progress view has now popped up, and in a few moments, the transfer will be complete, and you'll see an entry corresponding to that in the transfer history view. In the next video, we will create one more table using the data transfer utility, which will be related to the table that we just created. Using Teradata Studio's data transfer utility, we have now created one table containing the details of restaurants that have been awarded Michelin stars. From the transfer history view, you will observe that the number of rows that were transferred stands at 6501. So we do have a lot of data to work with. To create a second table using data transfer, let's right-click on the tables folder from the Data Source Explorer on the left. Once again, navigate to Teradata and then Data Transfer. Again, we will stick with the default for a smart load. And then from the dialog which pops up, let's hit Browse and then navigate to one more file which is included within the course materials. This is cuisine mapping.csv. We have already loaded the restaurant data into one table, but one piece of information which is missing is the type of cuisine served in each of those restaurants. The different types of cuisine covered in our dataset are available in cuisine.csv, and the mapping between restaurants and the cuisines is in this cuisine mapping.csv file. Let's select this first and choose to open it up. You'll observe that the column labels have been set to be in the first row, just as in our previous file. Moving on to the next step, this is where we can set a table name. The default is set to cuisine_mapping, as in the name of the file. This is set to be a multi-set table with no primary index. Let's leave things at that. From the preview, you will observe that there are two columns present here, restaurant ID and cuisine ID, which will map to a restaurant's data and the cuisine table, which we will soon create. Next, let's quickly confirm that the SQL definition looks good. Significantly, no primary index is explicitly mentioned as a clause. When we hit finish, it looks like this table creation is also a success, and it should not take long for this transfer to complete. You'll observe that a total of over 8,200 rows have been transferred, since there are multiple restaurants which map to multiple cuisines. Let's move on and create the cuisine table then, once again by initiating a data transfer for the tables under restaurants. Choose Smart Load, and then for the input file, we navigate to cuisine.csv. In this particular file as well, the headers are present in the first row. Moving to the next step, we leave the table name as cuisine. This time, let's set the primary index of type unique, since we do have a unique cuisine ID. As for the table type, this can also be set to set. Then there is the preview, which includes a cuisine ID column and a cuisine column. When we choose to finish, a third table has now been successfully created. And then expanding the tables folder, we now have three different tables in here. Starting from the next video, we will run queries against these in order to analyze their contents. We now have three different tables within our restaurants database, and all of these are related to one another. While it is possible to have foreign key references in Teradata, it is more important in a transactional database rather than in one used for analysis. In this demo and some of the demos following it, we will focus on some of the analysis operations which can be performed. For that, let's switch over to query development, since our analysis will be in the form of queries. Let's start off by setting restaurants as the default database. And once this has been accomplished, we start off by performing a rename operation to rename the Michelin 18 table to Michelin awarded as it was before. This is to cover how a rename table can be performed. And once this is complete, let's go on and quickly take a look at the contents of the Michelin awarded table. In Teradata Vantage, there is no limit clause, as is the case in standard SQL. However, we can get similar results by using the top n clause. Here, we select the top 5 from the Michelin awarded table, and we retrieve all columns by specifying star in the select clause. Running this returns to us a total of 5 rows in the query results. You'll observe that there is no ordering in here. However, we will later see that we can also include an order by clause to enforce some ordering. Scrolling along, we can confirm that all columns have been returned, and we now know that the top n clause can be used in order to constrain the size of the output. Let's move along then to one more type of query. In here, we introduce the where clause. In fact, looking at this query, you will see that there is no real variation from standard SQL. We specify 6 different columns in the select clause. The from clause points to a single table. And then in the where clause, we restrict our results to those rows where the currency column has a value of THB for Thai baht. Executing this query gives us back a total of 165 rows, as you'll observe from the Teradata SQL history section. All of these are restaurants based in Thailand, which is why the payment currency is Thai baht. And you can see that The restaurants are scattered across a handful of different cities, most of them being in the capital of Bangkok. Furthermore, the award column points to the fact that there is a Michelin award called Bib Gourmand, which is offered to restaurants which offer good value for money, in addition to excellent food, though it is a little different from a Michelin star. Alright then, now that we have familiarity with the where clause and some more idea about our data, let's continue with our analysis. Here we run a similar query as we did before, except we have two different conditions in the where clause. The currency can be Thai baht or the location can be Singapore. This means we should get back the same restaurants as in the previous query, plus those restaurants that are located in Singapore. On running it, sure enough, the row count in the results is 283, more than what we had previously. In fact, the use of the where clause is quite similar to standard SQL, as we will now see with the use of the AND clause. Here, we restrict the search to restaurants where the payment currency is Thai baht and which are located in the city of Chiang Mai, which is in Thailand. And in the results, we get back a total of 23 restaurants. So the location filter in here has trimmed the output from 165 down to 23. When trying to optimize any queries which we execute, it helps if we have an idea of the query execution plan, and in Teradata Vantage, we can get this by prefixing the explain keyword before any query. When this particular statement is executed, we don't get back the query results, but instead an explanation of how exactly the execution will take place. You'll observe that the first two steps which are included here are to do with a locking mechanism. Step number 3 points to an all AMP retrieve. AMP, you will remember, maps to virtual processors or virtual nodes across which the table's rows are scattered. Given that we don't reference the primary index column in our query, all of the AMPs will need to be accessed. Moving along, you'll observe that a spool is created in order to store the temporary data before some of the contents from the spool are returned as the query result to the user. Estimates for the size of data to be transferred, as well as the number of rows and the time taken for some of the steps are available here. For larger, more complex queries, the explain statement can help guide us towards some optimizations that can be applied to make our queries run faster. We will now continue performing an analysis of our data. Next, we will include some more conditions within the where clause. In addition to the currency being equal to Thai baht, we will also require that the location of the restaurant need to fall into one of three values: Chiang Mai, Phuket, and Nonthaburi. We do this with a combination of an AND clause and OR clauses placed within parentheses. Running this returns to us those restaurants where the payment currency is Thai baht and whose location corresponds to one of the three different cities specified. However, there is an easier way to accomplish the same results. Note that the row count in this query execution is 50, but if we simply make use of the in clause, which is available in most SQL implementations, and then execute, we get back the same 50 rows of data. And a quick examination of the results does confirm this. The converse of the in clause is not in. This will return to us those restaurants where the payment currency is Thai baht, which are not located in the following cities. So we get back those restaurants in Thailand that are located in Bangkok, Samut Sakhon, and cities that are not Chiang Mai, Phuket, or Nonthaburi. Moving along then, we apply a not operator, this time looking for those restaurants where the payment currency is Thai baht, but which are not located in the capital of Bangkok. The combination of the less than and greater than symbols make up the not operator when using Teradata Vantage. And from the results, we see that there is no mention of Bangkok at all. From the not equal to operator, let's move on to a range operator. In this query, we add the condition that the min price for a restaurant must be less than 30, that is less than 30 baht. So while the previous query returned to us a total of 71 rows, With this new filter added, we only get back a total of 4 values. In each of these cases, the min price and max price stand at 20 baht, and there is no restaurant where the min price is exactly equal to 30. To include those in the results as well, we simply replace the less than operator with less than and equal to. And we get back a total of 5 values. A restaurant in Chiang Mai where the min price is exactly equal to 30 now shows up. Moving along then, we can also make use of the between operator to filter for restaurants where the min price falls within a specified range. Note that the clause min price between 30 and 50 includes in the results those restaurants where the min price is exactly equal to 30 or 50 and all values in between. So the boundary values are included in the range. Next, let's quickly take a look at those restaurants which are located in Singapore, that is where the currency is Singapore dollars. We get back a total of 118 rows in the output, and you'll note that the awards are a mix of 1, 2, and 3 Michelin stars and also Bib Gourmand. To view the distinct values in the award column corresponding to the Singapore-based restaurants, we can run this query. We apply the distinct operator on the award column after filtering for the Singapore-based restaurants. When we run this, we get back the 4 different types of awards for these restaurants. The distinct keyword is also available in standard SQL, and it works in much the same way. Next, let's remove the filter for the currency and simply get the distinct values of award across the entire Michelin awarded table, and it is the same 4 values which get returned to us. So we know that the Singapore-based restaurants do cover the full range of Michelin awards. Let's use that then to continue with our analysis. And in this case, we look for the value for money restaurants, that is, those that have been awarded the Bib Gourmand Award, by searching for a pattern in the award column. Like in standard SQL, we use the like operator here, and a value of Bib percentage means that the string just needs to begin with Bib. When we run this, sure enough, all values in the award column in the returned results begin with Bib. So the like operator works as it does in standard SQL. One more confirmation of that can be obtained when we search for all award values which contain Michelin. So we include percentage symbols at either end of Michelin, so it can appear anywhere within the value, and we get back a mix of 1 Michelin star, 2 Michelin star, and 3 Michelin star restaurants. We now continue analyzing the restaurant data and will look for the 10 most value for money restaurants where the payment currency is euro. Here we first apply a where clause condition for currency is equal to euro. Then we order by min price. By default, this will be in ascending order. And then in the select clause, you will observe that we include the top 10 subclause. And then there are 5 columns which we specify. By virtue of the order by min price and the top 10, what we get back in the results points to the 10 lowest priced restaurants in the Eurozone. A lot of these are in the country of Portugal, just in case you're wondering. It is good practice to be explicit about the fact that the sorting of the results is in ascending order. Here we only include the ASC clause in order by. What we get back is exactly the same data in exactly the same order, but to any viewer of the query, it is clear that the ordering is ascending. If you would like to take a look at the other end of the price spectrum, well, we simply replace ASC in the order by clause with DESC for descending, and the results point to restaurants where the minimum price starts at 380 and then goes all the way down, if you will, to 305 euros. So the order by clause is similar to what you would encounter in most relational databases. And in fact, we can similarly order by multiple columns. In this case, we order by minimum price and maximum price, both in ascending order, which means that in the results, when there is a tie for minimum price, like in the case of those restaurants where the minimum price is 10 euros, the maximum price is in ascending order. A similar ordering also applies to those restaurants where the minimum price is 12. We can specify the ordering for each individual column. For example, we order by minimum price in ascending order, but then by max price in descending order. Here, the minimum price ordering is still the same as before. However, in case of a tie, you'll observe that is the restaurants with the highest maximum price which show up at the top. So we can apply a mix of ascending and descending order sorts for the different ordering keys. To get an idea of how this query will be executed by Teradata Vantage, we simply prepend explain to this same query. As we saw before, what we get back is an explanation which begins with a lock phase. Again, there is a retrieve step which scans all AMPs, and then there is a stat function which is applied to retrieve the top 10 rows in an optimal manner. We will now focus on update and delete operations on the restaurants data we've been working with. First, let's take a look at the different restaurants that are located in the city of New York. When we run this, we get back a total of 180 rows. And you'll observe that we have restaurants corresponding to various price ranges in here. And let's quickly confirm that there is no data corresponding to locations equal to New York City. Sure enough, there is nothing. Now, for the sake of our example, let's assume that there are some users who might query this data and who are not clear whether New York refers to the city or the state, in which case we wish to make it clear by referring to the city of New York as New York City. And for that, we change the value of location to New York City, where the location value is currently set to New York. And we do this via an update statement which includes a set clause. Assuming you're familiar with SQL, the statement will not be new to you at all. So we filter for the rows using the where clause, and then among those rows, we set location is equal to New York City. When we execute this query, from the SQL history section, we can see that 180 rows seem to have been updated. Just to confirm, of course, let's now select those rows where the location is equal to New York. We get back 0 rows of data, so it looks like the values in those rows have changed. And to confirm that they have changed to New York City, we query for those rows. And sure enough, 180 rows come back to us. We will now build our way towards updating multiple columns in a single statement. For that, let's first narrow down our search to those restaurants where the currency is the British pound or GBP and which are located in the city of Birmingham. Based on our dataset, there are a total of 5 restaurants that have been conferred some Michelin award in the city of Birmingham. You will notice that for most of these restaurants, the price ranges are somewhat similar, but for the sake of our example, let's just assume that due to intense competition, they have effectively equalized their prices. For that, we will need to update the minimum and maximum prices for all of these, and we can do that in a single query. We start off by only updating the minimum price first and set it to a hard-coded value of 50. When this is executed, 5 rows seem to have been updated, and then re-executing our previous select query shows us that the minimum price has in fact changed for all of these rows. Now, in order to update both the minimum and maximum price columns, we can run this query. The set clause now includes 2 different updates separated by a comma. We set min price is equal to 60 and max price to 100. When this is run, again 5 rows are updated, and our select query reveals that all 5 of those rows have the exact same values for min price and max price. From updates, let's work our way towards a delete operation. But for that, let's first take a look at the rows which we will delete. Here, we query for those restaurants for which we don't have a phone number. That is, where the phone number column is null. We can do this by including phone number is null in the where clause. Sure enough, the results point to null values in the phone number field for a total of 121 rows. If you would like to delete all of these from our dataset, we can run this query. The from and where clauses are exactly the same as in our last select query, but the entire select clause is replaced with the keyword delete. Running this seems to have affected a total of 121 rows. And to confirm that there are no longer any rows in our dataset where the phone number is null, we re-execute the select query and we get back 0 rows in the output. In the next few videos, we will focus on aggregation and join operations using Teradata Vantage. Overall, these are quite similar to corresponding operations in most relational databases. So I won't dwell too much on the syntax, assuming you're already familiar with it. Let's start off, however, by running this query to get the distinct locations for those restaurants where the currency is the Chinese yuan. From the output, we see that there are a total of 4 distinct cities which are present in our dataset. And now to see exactly how many restaurants there are scattered across these 4 cities, we perform an aggregation. Specifically, we count the number of different IDs corresponding to the rows where the currency is equal to CNY. That is, we make use of the count function to which we can pass along a column whose non-null values will be counted. We get back a value of 188, pointing to the fact that a total of 188 restaurants exist. Since individual columns may contain null values, a more standard practice to get an accurate count is to do a count star, where all rows containing even a single non-null value will be counted towards the total, and we get back the same value of 188. Here we have performed a count aggregation across the entire table, but this can also be applied to groups of rows within the table by including a group by clause. In this query, the from and where clauses are the same as before, but by specifying group by location, all of the rows corresponding to distinct values of location will be grouped together. In our case, given 4 distinct values We will now explore join operations that can be performed using Teradata Vantage, for which we will also need to consider some of the other tables into which we have loaded data. Let's start by exploring the contents of the cuisine table. I assume that the restaurants database is currently active, and from the output, we observe that there are a total of 239 distinct cuisines in our dataset, each of which has a corresponding cuisine ID. For joins to work, we will need the cuisines to be mapped to restaurants, and this mapping is achieved by means of the cuisine mapping table, whose contents we can now explore. The number of rows in the cuisine mapping table, however, exceeds the default limit that can be displayed by Teradata Studio, which is 2000. Let's just choose to truncate the output since we only wish to understand what the data is like. And there are cuisine IDs corresponding to the cuisine table, and then restaurants IDs mapping to the Michelin award table. Importantly though, the relationship between cuisine and the Michelin awarded table is many to many. Before that comes into play in a join operation, let's first filter for those restaurants in our dataset which are located in the city of Munich in Germany. The results reveal a total of 21 rows. There's a mix of Bib Gourmand and 1 and 2 star rated restaurants in here, but what we are more interested in are the cuisines which they serve. To get that information, we will need to perform a join operation. We'll start off with a single join between the Michelin awarded table and the cuisine mapping table. In the where clause, we restrict our search to the Munich based restaurants. Then in the from clause, we include Michelin awarded, which we will refer to as rest table. And then we perform an inner join using the inner join clause with the cuisine mapping table. And we will refer to this with the alias CMAP. When performing a join operation, we will need to specify a join condition, and this is done by means of the on clause following the inner join. So the rows in our Michelin awarded restaurant table will be mapped to the cuisine mapping table based on the ID in the restaurant table, resttable.id, being equal to the restaurant ID column in the cuisine mapping or CMAP table. In the select clause, we will project the name, location, award, and cuisine ID, and we order in ascending order of cuisine ID. And this is what we get back. In here, we have simply mapped restaurants to cuisine IDs rather than the actual values of the cuisine. But to get that piece of information, we will need to perform one more join, effectively joining this table with the cuisine table. And for that, we'll just need to modify this query so that two different joins are performed. And you'll observe that in my case, I have performed a combination of a right join and an inner join. A right join is one where all the rows on the right hand side of the join will be included, but only the matching rows from the left side table. Here we perform a right join between the Michelin awarded and the cuisine mapping tables, but in this particular example, you can just replace it with an inner join since the output will be the same. What is significant, however, is that we perform a second join operation with the cuisine table based on cmap.cuisineid being equal to cuisine.cuisineid. A slight change from the previous query is that we now reference the cuisine column in the select clause, and this can be found in the cuisine table. In fact, we also order by cuisine. When this is run, well, we get back the same 34 rows as we did in the previous query execution, but the last column points to the actual cuisine which is served in the restaurant. From rows 2 and 3 in the output, you'll observe that the restaurant of Tantris serves up two different categories of cuisine, classic cuisine and classic French. To implement left and right join operations, we will need to work with a different dataset, and I'm now going to create one corresponding to movies and their directors. Let's start off by creating a new database called movies. This will have a total of 60 megabytes of permanent storage and a spool size of 120 megabytes. Once this statement is executed, a new database should be created, and we will provision new tables in there using the data transfer utility. So let's switch to that perspective. and then expanding the DBC user under the connection, expand databases, and in my case, the movies database does not show up in this view since it has not yet been refreshed. I'll do just that by right-clicking on databases and then choosing refresh. And now movies does make an appearance in this list. To provision our new tables, let's just right-click on tables, head over to Teradata, and then data transfer. Since we have done this a few times before, I won't delve into the details. We'll launch Smart Load. For the input file, we'll navigate in the file system over to the movies.csv file, which is included in the course materials and is derived from this original dataset, which can be found at this URL on kaggle.com. Once the selection has been made, ensure that there is a check next to column labels in first row since the CSV file does contain headers. Moving on to the next step, we will leave the table name as movies, set the primary index to unique since the series title column is unique in here, and then set the table type to set. To confirm the schema definition, we head over to the next step. We can see that the information for each movie includes a series title, which could be the name of the movie or TV series, a release year, IMDb rating and Metascore ratings are also present, as is the number of votes gathered for the IMDb rating. Alright, let's finish with this table creation. And once the notification shows up, one of the two tables which we need for a join is ready. Right-clicking on the tables folder, we perform one more data transfer. Once again, we stick with a smart load from an external file. This time, for the input file, we navigate to directors.csv. After the selection, again ensure that the column headers will be considered. Then moving to the next step, we leave the table name as directors, and then taking a look at the preview, you'll observe that we have two columns in here, series title and then director for the director name. There may be multiple directors for each film, so let's create no primary index and leave the table type as multiset. You will notice that it is the series title column which is common to both movies and directors, and that will serve as our join column. From the SQL preview, we can confirm the creation of the table, and once this has also been generated, we are ready to perform our join operations. So we switch from the data transfer to the query development perspective, and then in the SQL editor, we change the active or default database for our queries to movies. And once that is done, it is time for us to perform a join operation, starting with a simple inner join. In the from clause, we include movies M on the left side, directors D on the right, and the join condition is m.series title being equal to d.series title. In the select clause, we explicitly refer to m.series title since both tables contain a column of that name. And then we also project released year, IMDb rating, and director. And this is the result which is generated. A total of 27 rows appear in the output. However, an inner join means that only those rows which include matches on both sides of the join will be present here. Also note that the movie The Matrix has two different directors, Lana and Lily Wachowski. What this output does not include are movies for which there is no matching director in our dataset, and to include those, we perform a left outer join between movies and directors. So it is just the nature of the join which has changed in this query, and we get back a total of 33 rows in this case. The movie Amadeus does not have a corresponding director in our directors table, and the same also applies to Reservoir Dogs and a handful of other movies. Our dataset, however, does include directors for which there are no corresponding matching movies, and to view those, we can perform a right outer join. To make things clear, I have included both m.series title and d.series title in the select clause. When we run this query, well, we get back a total of 36 rows. Some of the directors for which there is no corresponding movie in the movies table include Martin Scorsese, who directed The Departed, and Roman Polanski, who directed The Pianist. Since there were no matches for these directors, nulls have been padded for the movies related columns in this output. We will now explore how we can connect to a Teradata Vantage database from a Python application, and the IDE which we will use for this demo is Jupyter Notebook, which is available as part of the Anaconda package. If you already have Anaconda and Jupyter Notebook set up, or would rather use a different IDE which you're already quite comfortable with, you can skip this video and join me in the next one, where we will begin coding up our app. If you'd like to continue along and then download Anaconda, navigate in your browsers over to anaconda.com and then choose to download this particular utility for your own OS. For me, this is Windows. Once the download is complete, we can move on and open up this exe file for the installer, and the installation will be straightforward enough. We proceed to the next step, agree to the licensing terms and conditions, and you can choose to install it either for yourself or for all users on your machine. I'll stick with the defaults for the destination folder as well, and given that Anaconda comes packaged with its own version of Python, you can choose to set that as your default Python. I'm going to make that selection here and then proceed. And now that the install is complete, we'll move on to the final step and choose to finish with the installation process. Now that that is taken care of, to start up Anaconda, let's pull up the Start menu and navigate to the Anaconda PowerShell prompt. It is from here that we will launch Jupyter Notebooks. Once the prompt has been initialized, we can navigate to a workspace folder. I'll just enter the D drive and this takes me over to a Teradata directory I have created. And this is where I'm going to create the new source file which will connect to a Teradata Vantage database. So we'll launch Jupyter Notebooks from this location by simply running Jupyter Notebook. In a few moments, a URL will be generated, which we can use to pull up the web interface of this IDE. In most cases, the URL should have been loaded in your default browser. If that is not the case, make sure to copy it in its entirety, including the token value. And once you navigate to it in a browser, this is what the page will look like. In the next video, we will create a new Jupyter Notebook which will connect to Teradata Vantage. Having opened up a Python IDE where we can begin writing some code to connect to Teradata Vantage, if you are on Jupyter Notebooks, well, just head over to the New menu and then choose a Python 3 kernel. This will pull up a new notebook. The first thing I'm going to do is to give it an appropriate name by clicking on the title and then naming it Python Teradata Connection. Once the rename has taken effect, let's go ahead and add in some new cells for execution. But before we establish the connection to Teradata Vantage, we can switch over to Teradata Studio and then load our movies database table with additional data. By expanding the user and then over to tables under movies, let's right-click on the table and head to Data, Load Data. This will prompt us to switch over to the data transfer perspective. I'll just confirm that. And then for the data transfer wizard, we'll choose to transfer from an external file. Next, we'll choose the input file itself. And this is the IMDb top 100.csv file we'll be working with. This is part of the course materials and is also available at this URL. This is the comprehensive set of movies we worked with previously. Make sure to specify that the column headers can be found in the first row and then finish. In a few moments, new movies will be added over to the movies table, and we're now ready to connect to it from a Python application. Before we get there, let's head to query development and take a look at the contents of the movies table. This gives us back a total of 100 rows. These are the top 100 movies and TV shows on IMDb. And now we return to our IDE and install the libraries which we will need to set up our connections. We will make use of SQL Alchemy, which is a Python-based object relational mapper, and SQL Toolkit, to work with various databases. To install it, we can make use of the pip package manager. We run the command pip install with the no cache dir flag to disable the cache, and then set the upgrade flag so that if an existing version exists, it will be upgraded. Note the exclamation point at the start of this command. To run the cell, you can hit the run button at the top or shift enter or control enter using the keyboard. You'll see that in my case, I already have the latest version of SQL Alchemy, but if you don't, you'll likely see an installation take place in here. A library which builds on SQL Alchemy is Teradata SQL Alchemy, and that is what we install next. Once again using pip, can just execute this cell, and we now have the Python libraries which we need in order to connect to our Teradata database. That is what we will work on in the next video. Now that we have installed Teradata SQL Alchemy and its dependency SQL Alchemy as well, in order to establish a connection to a Teradata database, from the SQL Alchemy module, let's import create engine and text. Create engine will allow us to set up an engine which will serve as the connection object to a Teradata instance. The text function will allow us to create SQL statements using strings. Let's start off by initializing an engine with an invocation of create engine, and the connection string which we need to pass along will begin with Teradata SQL, which is the protocol : then the username and password separated by a colon. So for our Teradata database, the username and password we've been working with are dbc and dbc. Then the @ symbol is followed by the URL of the database instance. For me, the address of Teradata running in my virtual machine is 192.168.1.8. You will need to substitute your own address in here. Next, we set up a connection which will be used in order to execute a query and then process the results. We use a with block and then invoke eng.connect in order to get a connection object, which we then use by invoking its execute method in order to execute a SQL query. You'll observe that this is a select query which we transform into a text instance by using the text function of SQL Alchemy. The specific query in here is to select the series title, released year, and IMDb rating columns from the movies table where the released year is greater than 2015. This will return to us a result set, and we iterate over each row in the results and simply print them out. When we execute this cell, well, we do get back the data from our table, which confirms that our connection is successful. Significantly, you'll observe that each row object in here is in the form of a tuple and includes the 3 different fields which we specified. To be more precise, however, each row object is a named tuple, so we can reference each of the entities in the tuple by means of a name. Just as in the previous cell, we initialize a connection object and then call its execute method to run the same query. This time, when we iterate over the result set, we reference each of the individual column as row.series title, row.released year, and row.imdb rating. And when the cell is executed, sure enough, we get back each of those values. Now that we know how to retrieve the contents of our table using a Python application, let's see how we can insert rows into it. Here, when we initialize our with block, we call engine.begin in order to begin a transaction. Since this is in a with block, the transaction will automatically be ended at the end. But let's focus on what happens within the transaction. Specifically, there are 2 rows which are inserted. Let's see how exactly this is accomplished. When we call con.execute and pass along a text instance, that instance points to an insert query. So this is straightforward enough. Insert into movies.movies and then the different columns for which we will provide data. It is following the values keyword where things get interesting. Here we effectively supply placeholders for the series title, released year, and the 3 other columns by making use of a colon, and then the actual values to be substituted in those places are supplied in the second argument to the execute function. Here we supply a list containing 2 dictionaries, and in each dictionary, we specify the values corresponding to the various fields to be plugged into our insert statement. In the first insert statement, the details for the movie Top Gun Maverick, which was released in 2022, will be placed in, and then a second insert statement will be created for the TV series Stranger Things, launched in 2016. When this is executed, 2 rows of data should have been inserted, and we can confirm this by rerunning the select query which we ran previously. And in the results, we can see at the bottom both Top Gun Maverick and Stranger Things, the 2 entries which we just added. From inserts, we can move along to update statements, and this works in much the same way as the insert operation did. We instantiate a transaction with a call to engine.begin, and then invoke the connections execute method and pass along an update query string in order to update the IMDb ratings for a few series. In the first update statement, which will be executed, the rating for Stranger Things will be updated to 8.9. In the next one, Dunkel's rating will be updated to 8.7. And then finally, Joker's rating to 8.1. After running this, we run a select query again, and we can see each of these 3 updates in the results. And then we can carry out a delete operation. Once again, we begin a transaction and then execute a delete from movies query, and we will substitute the series title values for 3 different movies in here. And just to confirm the delete, let's run a select, and sure enough, those 3 titles no longer appear in the results.